Welcome back. In 1913 and 14, Moseley carried out a systematic study of characteristic X-ray of various elements used as targets. And by studying all this, he derived a law known as Moseley's law. And by studying targets of different elements, he found that spectra of different elements are similar to one another with only a few important differences. The spectra of the X-ray spectra of different elements is found to be similar with few important differences. The frequency of lines produced from an element of higher atomic number is greater than that produced by an element of lower atomic number. The frequency of line produced by an element of larger atomic number will be large, and that of an element of lower atomic number will be less. It is because with the increase in Z, or with the increase in the atomic number, the binding energy, with the increase in the atomic number, there will be increase in the binding energy. There will be increase in the binding energy because of the greater positive charge in the nucleus. Large amount of energy is required to remove an electron from the innermost shells, and therefore the binding energy is said to be more with larger Z. So if you consider a K alpha line of characteristic X-ray of any element for that matter, it is found that higher the atomic number of the target material, higher will be the frequency of K alpha line produced. We are considering K alpha of characteristic X-ray, and that depends on Z. If Z is more, then the frequency of K alpha line is more. If Z is less, the frequency of K alpha line is also less. Therefore, there is a direct relation between Z and nu, frequency and atomic number. And the relation between the frequency and atomic number is given by nu proportional to Z minus B whole square, or square root of nu proportional to Z minus B, or square root of nu equals A into Z minus B, where A and B are constants for a particular series of spectral lines. The constant B is called the nuclear screening constant. For K series it is 1, for L series it is 7, and so on. Also A equals 3 Rc by 4 for K alpha, A equals Rc by 9 for K beta, and so on. And the above relation is called the Moseley law for characteristic or line X-ray spectrum. And the law can be stated as the frequency of spectral line in the characteristic X-ray spectrum varies directly as the square of the atomic number of the element emitting it. Frequency of spectral line in the characteristic X-ray spectrum varies directly as, or is directly proportional to square of the atomic number of the element which is emitting this particular characteristic X-ray spectral line. And this is the diagram which shows the Moseley lines of K alpha and K beta lines, and both are linear. It is a function of both frequency and atomic number. As the frequency increases, the atomic number also increases, or as the atomic number increases, or the atomic number of the target element increases, the frequency of the emitted characteristic X-ray spectral line also increases, and the increase is linear as shown in the graph. And this is the exact form of the Moseley's law, which is 1 by lambda equals R into Z minus sigma whole square into 1 by N1 square minus 1 by N2 square, where capital R is called the Rydberg constant, which is a constant again. Z is the atomic number of the target. Sigma is the correction factor, and N1, N2 are the principal quantum numbers of the energy levels between which the transition takes place. K series has maximum energy and thus gives rise to the hard X-rays, but L series will have lesser energy compared to K and therefore will give rise to soft X-rays. Thank you. And these are the importances of Moseley's law. And this law provides the proper guidelines that the elements must be arranged in the periodic table according to the atomic numbers and not according to atomic weights. This law gives the guidelines to arrange the elements in the periodic table according to atomic numbers, according to Z. This law led to the discovery of new elements like the hafnium with Z equals 72, the promethium with 61Z, the technetium, rhenium, etc. by the indications of gaps in the Moseley's diagram. It has been helpful in determining the atomic number of rare earth elements, thereby fixing their positions in the periodic table. It can be shown that the law is in accordance with Bohr's theory of spectral emission from the atoms. So these are the importances of the Moseley's law.